Welcome to this Spitfire Tech Talk about port forwarding. Port forwarding is a useful technique used in conjunction with NAT to enable you to host servers that are publicly available on your own network when you have a NATed connection from your ISP. To connect your internal network to the internet, you'll be using an IP router. The ISP connection might be broadband or Ethernet, it makes no difference. The device connecting your local network to the internet will be that router, which most often is supplied and managed by your ISP. And a very common deployment nowadays is that your router performs a network address translation function, or NAT. For the internet to work, every device needs to have a unique IP address. However, the internet has now effectively run out of IP version 4 addresses. They've all been assigned. So to make the best use of the IP addresses the internet has left, NAT is used to translate from a private IP address to a public IP address as traffic goes through the router out onto the internet. The most common NAT scenario you come across is, certainly for small businesses and all home users, is that the router is allocated a single public IPv4 address. And this special case where there's a single IP address involved also gets referred to as PAT, Port Address Translation, and in the Cisco world it gets referred to as NAT overloading. And NAT works very well for things like web browsing, and most modern applications are written and deployed for NAT environments because it's now so common. There are occasional applications you'll come across that have problems with NAT, but by and large all those issues are surmountable in some way or other. So NAT is pretty ubiquitous. So in this concrete example, we have private IP addresses for all the devices on the LAN taken from the RFC 1918 range. And as the IP packets go through the router will swap out the private IP address that are on the devices on the LAN with the public IP address in the packet header, so that when the packet reaches the destination on the internet, the packet can be returned to a public IP address which is routable. And the router keeps track of all these packets going in and out, so that multiple PCs, multiple devices on the internal network can share that one single IP address. That's great for devices on the internal network that are initiating connections out to the internet. However, there are occasions where you might want devices on the internet to initiate an inbound connection to the internal network, and this is where port forwarding gets used. A common example is that you want to run a server available to internet users, such as a mail server. Some customers have hosted mail, other customers still want to be able to have their own mail server on site, and in order to get mail from the internet, that needs to be publicly available. When you connect the email server and configure it, it's going to have a private IP address from the range that's on your local area network. And the mail server can send mail out in the same way that a PC can initiate a connection out, because as the mail gets sent out, the private IP address will get translated by the router into the public IP address. So sending mail out is not a problem. But what we need is a way of getting mail from a public IP address on the internet through to the private IP address on the LAN. And this is what port forwarding does for us. Now, the only public IP address that you got in this scenario is the single IP address on the router that's on the WAN connection to the ISP service. That's the one that's used to translate the outbound traffic. So this is the only IP address that the rest of the world can get to. So this is your internet identity, if you like. So this is the IP address that you have to tell everybody to send their traffic to. In the case of email, what you need to do is to publish that public IP address in the DNS records. So in the case of email, that will be a host name for the mail server. So you create a host name record using the public IP address, and then create MX records that reference that host name, so that all your incoming mail comes into this public IP address. That will be something you do yourself if you run your own domain names, or if your ISP runs your domain names, then you need to ask the ISP to configure that for you. Now, incoming mail will be coming in using the Simple Mail Transfer Protocol, SMTP, and that works on TCP port 25. All applications have assigned to them a transport layer number, so that you can identify different services as they connect in at the transport layer. The most common ones are referred to as well-known ports because, well, everyone knows them, or at least if you're a network administrator, you know these ports. So SMTP uses the well-known port number 25. If you've never seen this nomenclature before, the port number is added using the colon notation to the end of the IP address. So you might see this in a URI for a website where a different port number is used. It's appended to the end using a colon. So what we're saying here is incoming SMTP comes in on 62.133.23.2 port 25. So what happens with port forwarding is that the router is configured to send all IP packets coming in on port 25 to the mail server on the LAN. So in this case, we say that we're forwarding port 25 to 192.168.100.60, which is the private IP address of the mail server sitting on the LAN. So the mail server will receive the incoming mail just as if it had the public IP address 62.133.23.2. So we can receive mail from the rest of the internet, and so far as the internet is concerned, we are running a mail server on that public IP address. Now let's say you also want to run a web server on the LAN as well as a mail server. Web servers, web browsers, use the HTTP protocol, and the well-known port number for HTTP is port number 80. So by default, a web browser will try and make a connection to a website on TCP port number 80. So what we would do is configure the router to forward all traffic coming in on TCP port 80 to be forwarded to the web server. Note the web server is a different server that has a different internal IP address to the mail server, and this is no problem. That the mail server carries on collecting email coming in on port 25, and the web server deals with all the traffic coming in on port 80. So the web server is accessible to all internet users effectively on that public IP address. So you can make any server you want available to internet users. You just have to know the port number on which it's running, or listening as we say. So here are a few examples of the most common port forwards that we get asked to configure for customers. There are 65,000 odd possible port numbers, but these are the most well-known ones, the most common ones. I should add a word of warning that when doing port forwarding, what you're doing is opening up the servers on your network to the whole of the internet, and the internet has good people and bad people. So before you do this, you need to consider security and whether you want to restrict access to only certain IP addresses. And we would normally restrict access using access control lists in conjunction with the port forwarding to only allow access to specific IP addresses that need to have legitimate access to your servers. In the example of a mail server, if you're collecting mail from all internet users, that would need to be open to the whole of the internet. But it's very unusual that you would want to expose, for example, your database server to every user on the internet. So you would probably want to restrict that to specific IP addresses that need to connect to your database server if you're going to expose that at all. And the same applies to RDP and to SSH. you have an opportunity on the router to configure ACLs in conjunction with port forwarding to only allow certain incoming connections from certain IP addresses. One of the limitations of port forwarding is that you've only got one public IP address, so you can only port forward each port once to one server. So if you've got a situation where you have two web servers on your internal network, you can only port forward port 80 to one of them. And so this might be a problem, but there are usefully a couple of ways around it. One of them is to simply use different port numbers for the different services. So for example, we have customers that have CCTV cameras on their internal network that all run, for example, on port 80. And the customer might want to remotely view the CCTV cameras over the internet. So what we do is configure different port numbers for each of the cameras. So these are external port numbers, so when you're connected over the internet you would append that port number to the end of the URL. You don't have to change the internal port numbers on the cameras. There's no reconfiguration needed on the cameras. All the clever stuff is done on the external router, and you just need to remember that when you're viewing these cameras from the internet you need to add on to the end of it this additional port numbers. So back to the example where we're trying to run two web servers on the LAN. You can't run them both on port 80, but what you can do is run one of them on a different port number. Port 8080 is commonly used for a second web server, and so what you'll do, you'll have a URL for that second web server, something like this, HTTP, whatever the domain is, and then colon followed by the port number at the end. When you type that into the web browser, it knows to make the connection on TCP port 8080, whereas by default, if there's no colon number at the end of it, it will use port 80. That's the well-known port number for HTTP. And that all works fine, and for technically savvy people and for internal users, that's a good solution. The marketing people don't like to use things like this because it makes the URL longer. It makes it more complicated for users, particularly if you're publishing URLs like this in printed materials. It makes it harder for users to type in. Users can't find the colon on the keyboard, that kind of things. So that's a consideration where you might not want to put a public-facing web server onto a different port number. You might want to use that just for servers that internal people are using. So another option you have is to do virtual hosting. Virtual hosting is where you run multiple websites all on the same server, the same physical hardware, which is going to have one single IP address. I think it's fair to say now that 99% of all websites on the internet are done using virtual hosting. If you go to a hosting company, then you rarely get your very own physical server sitting in a rack. What you have is a server with a single IP address that runs hundreds of other websites from hundreds of other customers. And the server can see the HTTP request, and in that is contained the host name and the domain of the request. So the server knows to serve up which pages from which website for the incoming request. So you can put more than one website on the same IP address and just use one single port forward. So all the websites are accessible on port 80, they're just all running on the same server. The downside of this is all the websites are running on the same server, so there might be business reasons why you might not want to do this. One of the bogus reasons people say they can't do virtual hosting is that they're using SSL, or TLS as it's now known. TLS SSL encrypts the HTTP message, which is a good thing, that's the whole purpose of it. But it means that when the HTTP message gets to the server, it can't tell which website the user is sending the request for. So what this means is the server can't tell different websites, so traditionally you can't run multiple websites on the same IP address. However, this is a problem that the internet boffins looked at a long time ago, and they invented something called SNI, server name indication. And what happens in SNI is the website you're trying to connect to is sent in clear text. That's not a problem. That's not a secret where you're trying to connect to, and so the server can see in clear text the site you're trying to connect to and make the connection to that particular website, and then all the rest of the website is sent encrypted. SNI is widely supported now. Practically all modern web servers will support SNI, and all modern web browsers also support SNI, so there's no real reason nowadays you can't do virtual hosting even on servers running SSL. All the examples so far, we've had the public servers on the same LAN. We've indicated that they're on the same LAN as all the PCs. We mentioned security considerations, and in order to address security concerns, some customers will choose to deploy their servers on a separate LAN from their internal users. And this separate LAN is often referred to as a DMZ, or demilitarized zone. So DMZ is a feature you typically see on a firewall or a firewall router device. So in this case there will be two separate LANs with two sets of private IP addresses. They're still running on private IP addresses, but you have separate LAN from the servers and the users, and sometimes that's done for two reasons. One is that if one of your servers is compromised, then the hackers have not got access to your internal network, and the other is you might not want your internal users to be able to connect to all these servers anyway. The most common scenario where you're deploying a firewall with separate DMZs is that the firewall will sit behind the internet router, and it will be the firewall that's performing the NAT functionality and the port forwarding and the access control lists, and the router will be configured in no NAT mode or just plain routing mode. It'll be offering a subnet, normally a /30, to the firewall. So from the /30, the firewall will take one of the IP addresses, and the router interface, the internal LAN interface, will take the other IP address from the /30. You can get devices that do routing and firewall all in one, but it's more common to keep this demarcation and have the two separate devices, mainly for troubleshooting purposes. Normally the ISP is managing and controlling the internet router, so if there's a problem with the service, the ISP can log into that router and do some troubleshooting to resolve the issues. And it's most common that the firewall will be installed and controlled by the customer or the customer's IT company, so that they're retaining control of their security. They know what the security policies are on their firewall, and they're responsible for maintaining that. So, quick summary: port forwarding is a technique used in NAT scenarios that allows a customer to run their own internet servers where there's just a single IP address. That's a very good thing. It makes efficient use of IP addresses, IP version 4 addresses. In IP version 6, there's no need to use NAT. We've got trillions of IP addresses. So if you're interested in IP version 6, which is the future, check out some of our other videos that explain how IPv6 works. Thank you for watching. Hope you found it useful. Please let us know one way or the other. Thank you very much.